Right. Now, what is very important here, people, is that we know the difference between alternating current and direct current. Okay. The best example to explain it to you is alternating current is what we use in our homes. Alternating current is what Eskom generates. Okay. And the main reason why Eskom generates alternating current is because alternating current, you can change the voltage. In other words, you can step it up or you can step it down. I'm going to get to that a little bit later and then I'll explain it again. Right. Now, what happens is the turbine, which in South Africa we use water and then we heat the water with coal and it causes steam. The steam turns the turbine and this turns in here. Right. And it then generates the current. Okay. Alternating current, you can have a look here. When the coil is at 0 degrees, you will have no current. And when it is at 180 degrees, you will have no current. Right. At 90 degrees and at 270 degrees, you will have maximum current. Right. So your graph is going to look like the one on your screen at the moment. Okay. Most of you do maths. As a matter of fact, I think all of you do maths. And you will know that that is what a sine graph looks like. Right, that is what a sine graph looks like. Right. Now, that point, the highest point over there, is known as my maximum voltage. Right, the lowest point is also maximum voltage, but remember it is in an opposite direction. Now, my current graph looks very, very similar to this one. And you have to be able to draw the alternating current graph, and you have to be able to draw the direct current graph. This slideshow is quite nice because I'm going to show you the difference now. Right, there is my alternating current one, the red one, okay? The blue one, right at the top at the moment, is what we call my direct current. Which one is my direct current? That is the one that comes from my battery, okay? And this is my alternating one. That sign over there means it is alternating current. Okay. Now, can you see what happens over here? Right, let's just stop there. Can you see what happens over here? My voltage is a red graph, okay? Right? And now, can you see that on this one, that is my alternating current, while this one is my direct current, okay? Right. So I always say your direct current looks like little frog jumps, okay? While your alternating current is your normal sine graph that you do in maths. Now, what is important for you to remember here is that we never work with maximum, right? And why don't we work with maximum, people? Because it's not always going to be maximum. Remember, these coils are turning. So at some stage it's going to be 0 and then it's going to be maximum. Okay? So we work with what we refer to as the root mean square. In other words, the RMS. Right? Now the RMS, all the RMS is, it is the maximum voltage or the maximum current divided by the square root of 2. Right? These you get on your data sheet. I'll show you the formulas just now. Yeah, you can have a look. IRMS is going to be equal to Imax divided by the square root of 2, while VRMS is going to be equal to Vmax divided by the square root of 2. And then we are going to use formulas like the average power is equal to VRMS times by RIMS, or power is equal to I squared RMS times by R. But we're going to have a look at all of these in a little while. So don't stress about it. All I want you to know at the moment is the difference between an AC graph and a DC graph. A graph from an AC generator and a graph from a DC generator. Remember, alternating, it changes. So your alternating one does that, while your direct current one jumps like that. Right. Here is an example of one. Let's quickly see. They say to us, I think let's quickly start on the left-hand side here. Right. They say to us, I max is equal to V max times by R. Okay, now let's quickly have a look. What is V max? That's V max times by R. Right. So, if we go, right, VRMS times by the square root of 2. Yeah, we carry on. I just want to, I'm confusing you people here now. So I think let's just skip this one for a moment. I'm going to do a better question on the paper just now. Let's have a just look again. Can you see that this is an AC graph and they gave you the maximum voltage, right? So you could have calculated the RMS. You would have said the RMS is equal to the maximum, or they've given you the RMS. Can you see there? There they've given you the RMS. Right, okay, and then we can work it out. All your normal electrical equations you also use here, like V is equal to RI and all of those as well. Right, now this is what I spoke about just now about the power transmission. Right, now this is what happens at our power stations, okay? What happens at our power station? Here's my power station. On the left-hand side, you can see all the smoke there. So what is happening at my power station? They generate the current, okay? And if they transport the current at 25,000 volts, we are going to lose approximately 6,000 watts of power, right? The scientists did a lot of maths and they said, no. If we now transport it at 250,000, in other words, 250 kilovolts, we are only going to lose 4.8 watts. Right. And this is the reason why AC current is much more favored than direct current. Because AC current, they can change the voltage. Right. So what happens is once the power has been generated, they step it up. Okay? They step up the voltage. So they step up the voltage to 250 kilovolts. Right? And they transport it all the way from Mpumalanga there to near Vicksburg, if you're living in Vicksburg. And those of you living at Tsotsiletso, all the way to your houses. And just outside your house or outside the town that you live in, there's a substation. And at the substation, they step it down again to 13 kilovolts. And then, just before it comes into your house, they step it down even further. Right. Okay. We work on, I think, 220 volts, if I'm right. Okay. So that is what happens with the electricity. And that is why alternating current is more advantageous than direct current, because you can step it up and obviously step it down. All of us have cell phones. Your cell phone charges, people step that current down up to 12 volts. Right, that's why your cell phone charger looks the way it does, okay? Because it changes it to 12 volts so that your charger can then work. The same as computer chargers, all those kind of things, right? Okay, now let us see, I've said quite a lot, but let us see if we can apply what I've said. Because that ultimately is the most important thing for us. Right, I've brought a few questions along. The first question I have over here says to us, we have an electric motor. Right, we have an electric motor, and that electric motors are very important to us. They are very important components of many modern electrical appliances. AC motors, AC meaning alternating current, are used in washing machines, vacuum cleaners, while DC motors are used in toys and tools. Right, this is something you can somewhere go and learn, because you could be asked, where are AC motors used? Right, we use those in our house, our washing machines, our tumble dryers, our vacuum cleaners, all those things, our hair dryers. Right, while our DC motors, they use in toys and in tools. A lot of our tools have DC motors in them. The jackhammers on the side of the road, when they're busy going through the tar, they have generators that are DC and things like that. Right. Now, what energy conversion takes place in an electric motor? Remember, people, an electric motor converts from electrical, right, so it's electrical energy, maybe we should put energy with it, to mechanical energy. Okay, that's something we learn as well, right? What does a motor do? Now they say to us, what is the essential difference in design between DC and AC motors? Now, you can remember what I said just now. Right, yeah, I still drew it for you. Okay. The essential difference in design is that AC motors have got slip rings, right? And they make use of alternating current. Right. They make use of alternating current. Okay, and I know all of you have got the next answer already. I'm sure of that. So what do DC motors do? DC motors have split rings, right? And they ensure that there is, they have split rings which ensure that there is continuous rotation. Right, okay. So your main difference is that the one has slip rings while the other one has split rings. And then, of course, the one that has split rings, they then make use of direct current.